Hello, my name is YuHong Fan, and this is my video homework for MHF4U Unit 3 mid-unit assignment. And I make this video to solve some related questions. So my first question is describe what happens to the domain and range of logarithmic function and a vertical reflection, and support your explanation with diagrams. Okay, so let's just so first of all please look at this this graph and this diagrams. I graphed it, which is the very simple and very basic function, logarithmic function, which is fx equals to log base 2x, and it looks like this. And we have the changed function, which has a vertical reflection over y equals 0, which looks like this. And for the first one, our original one, we have the domain, which is x can be any real number but bigger than 0, because we have the vertical asymptote, which is x equals to 0. And we have the range, which is y can be any real number. And for the vertical reflected function, which is inverse x is equal to log base 2 and negative x. And we have the new domain, which is x can be any real number but smaller than 0 instead of the original one, which is x bigger than 0. And we have the new range, but this one just keeps the same. We have y can be any real number. So here comes to our conclusion. That is, the domain would be any real number but smaller than 0. Well, that of original function was bigger than 0. And the range will keep the same, because the term vertical reflection means reflection about y-axis, and the reflection of logarithmic function is decreasing function. So on the other words, if you have the original domain, which is x equals to x can be any real number but bigger than a number, which the number can be any number, say 0, 1, 2, 3, 4, 5, 6, whatever. And if you make the same function reflect over y equals 0, which is vertical reflection, and your new domain would be smaller than the original number, which is the vertical asymptote. So that is the of course our range will keep the same no matter how. The range will keep the same if you only apply some vertical reflection. Okay, that is for our first question. And for the second question, please describe what happens to the domain and range of a logarithmic function under both a horizontal and a vertical translation. Support your explanation with diagrams. Okay, so for the next question, we have this graph. As well, we use the explanation, the very simple and basic one, which is y equals to log base 2x, and the graph just looks like this. So also we have the same domain, which is x can be any real number but bigger than 0, and the range is y can be any real number. And next, we apply two translation for the function. The first one, we applied a horizontal shift, which is 1 unit to the right. We can write it down as -1 here. And the next, we applied a vertical shift 1 unit down, which can be right here, just outside of this, which is -1. So we have a new diagram, we have a new graph like this here. I know those two graphs supposed to look like the same one, just shift, but like I just wrote it down by my hands, so whatever. And we have the new domain range. The new domain would be x can be any real number but bigger than 1, because we only have one unit change on horizontal shift. And also this one can be our new asymptote, which is obviously can be -1. No negative. I'm sorry, it's not -1 because it's the x value, so it's because it's -1, so it means we just shift it to the right instead of to the left, so it became 1 from 0. So our new asymptote would be 1, x equals to 1. So our new domain would be x can be any real number but bigger than 1 instead of bigger than 0. And our range would be the same, no change at all. So that would be y can be any real number, just as the original one. So our conclusion is, if horizontal shift, the domain will change. The new asymptote will be the number that all the x value must be bigger than, while the range will not change at all. So if vertical shift applied, neither domain and range will change, just as what I showed you guys just. So on the other words, or shortly speaking, only domain will be changed if both a horizontal and a vertical translation apply. Okay, so that is for our second question. Let's go on to the last one. For the last one, first of all, we need to graph a function, which is f(x) equals to 1/2 log x minus 4. It's this one. I just graphed it like this. We have a graph like this. And the next thing we're gonna do is graph the line y equals x on the same grid. Okay, so which is here, y equals to x, just a straight line over, just cross the O point, and then just like this. And the next question we're going to do is graph the inverse function of inverse x by reflecting fx in the line y equals x. It's simple and easy. We just here you can see the inverse graph is here, the same graph, you just reflect it. And first thing we're gonna do is to select a point, which I selected 1 and -4. You just switch the x, y value, which is x became y and y became x, which will be -4 and 1 in here. And then you just graph the line like this. Okay, the next question will be determine the domain, range, and the equation of the asymptote of I inverse x. So here is our third question. So for the first one, we have the domain of the new function, which is x can be any real number. You can see here x can be any real number, but the range will be different, which is y can be any real number but bigger than 0. You can see clearly here y can be any real number but bigger than 0, because for the new one we have no point which the y value is smaller than 0. You can see there's no any points here, so that means our range is y can be any real number but bigger than 0. And for the equation of the asymptote of f inverse x is y equals to 0, which is this line here, y equals to 0. So the situation is totally just different, and the inverse of those two functions. And for the last one, we need to determine an equation for f equals x equals to x. Here we have the steps. So first of all, we need to write it down, the original function, which is fx equals to 1 over 2 log x minus 4. And first thing we're going to do is just change the fx to y. So we have y equals to 1 over 2 log x minus 4. And next step, we need to switch y and x, which is change the y to the x. So we have x equals to 1 over 2 log y minus 4, our new one, because it is an inverse function. And next step, we need to solve for x. We need to solve for y. So first of all, we just select log y to the right side, left side, and then in order to get rid of a minus 4 and 1 over 2 times, so first of all we're gonna plus 4 to the both side, and then we need to multiply 2 so we can make 1 over 2 0. So we have this step, and next one we just solve for this operation, which will be 2 times x plus 8. That is log y equals to times x plus 8. And then we solve for log y, because log y can be log base 10 and y. So that means for this operation means log 10 raised to 2 times x plus 8 is equals to y. So that is our almost the final step like this. Okay, so now we almost done this. So for the last one, we finally successfully solved y, which is y equals to 10 raised the times of 2 times x plus 8. And for the last one, we just change the y to the f inverse x. So now we have the final answer, which is f inverse x is equal to 10 raised to 2 times x plus 8. Okay, so that's it. That's all we have for today's video homework. I hope that I have done it well. Thank you for watching and listening. Bye.